The proof is in the sun. The sun is not a constant factor. This fact is well known, but it is being ignored. It is assumed in the global warming climate change theory that the sun's energy output never varies. It is called the solar constant. On this basis, it is assumed that when the climate is changing, then terrestrial factors must be causing the change. On this platform, the humble CO2, the carbon dioxide in the air that all life depends on, so that none of us would exist without it, has been selected to play the villain that carries the blame for all the climate changes on Earth. What does this mean in real terms? Let's take a closer look. CO2 is a rare trace gas in the atmosphere at a density of 390 parts in a million. No one disputes this. Now, let's make some comparisons to see what this means in a rational context. Let's make a comparison with Mount Everest. Let's compare our humble CO2 with the tallest mountain on Earth, which is Mount Everest, that reaches 29,000 feet into the sky. By a simple calculation, a millionth of the height of Mount Everest comes out to be roughly a third of an inch, the size of a raisin that one bakes into a cake, or the size of a button on a person's shirt. Now, 390 of these, according to the CO2 ratio, when laid out in a row, would add up to roughly 11 feet, or twice the height of an average person. A person, when compared to the mountain, is so minuscule in this vast landscape that one would require a powerful telescope to make one out, like a climber on the mountain. Nevertheless, this one person on the mountain, as only a part of the mountain is seen in this picture, would be the equivalent of the total carbon dioxide content in the atmosphere. Thus, this one single person in the entire vast landscape before you is the comparative equivalent of all the CO2 in the atmosphere. One person on the mountain is far from being a gigantic factor, is it? Minuscule, I would call it. Now let's look at what the man-made contribution is. In a 2003 paper, The Ice Age is Coming, the chairman of the Scientific Council of the Central Laboratory for Radiological Protection in Warsaw, Professor Zbigniew Jaworowski places the man-made contribution to the CO2 pool in the range of 0.05% to 0.25%. By a simple calculation, this adds up to a man-made portion of 1 part in a million. If one takes the worst-case factor of Jaworowski's presentation, 0.25%, and one applies this to the 390 parts per million of the CO2 in the air, then one ends up with 1 single part per million for the man-made contribution, which is the size of a raisin or the size of a shirt button in comparison with Mount Everest. One might be able, with a powerful telescope, to make out a person on the mountain, but one will never be able to make out the buttons on that person's shirt, one of which represents the total man-made contribution of carbon dioxide in the air that the carbon politics hoopla is all about, for which the economies of the world are being decimated, and heavy taxes are imposed that devastate people's budgets from the personal to the national level. It is self-evident from this comparison that the man-made contribution to the global CO2 pool is absolutely insignificant in the overall climate dynamics. A raisin in comparison with Mount Everest is far too minuscule to be a factor for anything. For this minuscule extra portion of CO2 in the atmosphere, the size of a raisin or a shirt button in comparison with Mount Everest, society is presently killing 100 million of its people every year by burning their food in automobiles and by preventing the economic development of the world under the global warming doctrine. Genocide is the evident intention. That's insane, isn't it? And it gets worse still. In addition to all this, the minuscule amount of CO2 responds in only 3 narrow bands of the solar irradiation spectrum, and those are located at the low energy end of the solar irradiation spectrum, while oxygen and water vapor do respond to the entire irradiation spectrum. It doesn't take a great genius to realize that this 1 part in a million that humanity is adding to the CO2 pool at the lowest intensity end of the spectrum has absolutely no effect on the climate whatsoever. "450 million years ago, CO2 was 14 times greater than it is today, and this massive amount didn't prevent one of the severest ice age periods in geologic history that caused the second largest extinction of life. Our concern should be that the world is presently severely CO2 deficient. It is at the lowest level ever, near the biological starvation level. Without CO2, not a blade of grass would exist, or tree, or bird, insect, or a human being. The CO2 starvation is presently so severe on this front that when greenhouse operators double the CO2 in their greenhouses, a 50% increase in plant growth results. The man-made global warming climate change hoopla has evidently nothing to do with anything real about CO2, but is a coldly calculated political project to keep society scared, hungry, dying, and impotent, and as of late, killing one another under the depopulation doctrine. Now, let's look at what really affects our climate. Clouds affect our climate. They have a huge effect on our climate, as their white tops reflect the incoming sunlight back into space. It is a common experience on Earth that cloudy days are colder, which is a natural result of a large portion of the sun's radiated energy being reflected back into space. This energy is lost to us. The lost solar energy that the clouds reflect back into space can be quite significant. It increases with the increase in cloud formation. The intensity of cloud formation is not a constant factor. It is influenced by many contributing factors, and some of these are big factors. One of the biggest influential factors in cloud formation is the factor of cosmic ray density. During a recent conference in Germany, the Russian physics scientist Professor Sergei Pulinets points out that a close correlation exists between cosmic rays and cloud formation. When cosmic rays interact with the atmosphere, the resulting intensely violent collisions create showers of secondary particles, including muons, and a number of secondary elements and molecules. Cosmic rays ionize the nitrogen and oxygen molecules in the atmosphere, which leads to a number of chemical reactions. Some of these become nuclei for aerosol formation, for cloud formation. During the collisions, some rather exotic elementary particles are also created, of which the muons are of special interest. The muon is a basic subatomic particle similar to an electron, but is 200 times more massive. However, it is an unstable particle with a mean lifetime of 2.2 microseconds. Being short-lived, the muon doesn't travel far. This means that cosmic ray interactions occur close to where the muons are detected in the atmosphere. It is interesting what we find in those regions. Professor Sergei Pulinets from Moscow presented in Germany a 2009 study by Osprey et al. That shows an amazingly close correlation between muon density and cloud temperature. The correlation is so close that the two graphs almost totally overlap. This is significant because during the physical process of cloud formation, a significant amount of latent heat is being released. The resulting extremely close correlation of muon density with cloud temperature proves all by itself, without a shadow of a doubt, that cosmic ray flux directly affects cloud formation in a big way. When Professor Sergei Pulinets spoke at the Schiller Institute conference in Germany, he spoke about the reason for the heat buildup during the cloud formation. He explained that when atoms or molecules become ionized, water vapor molecules become attracted to them because the water molecule, though being electrically neutral overall, does have an electric dipole structure that causes the water molecules to be attracted to both positive and negative ions. He calls the process ion hydration. He explained further that the binding together of the water molecules releases the latent heat that had been previously invested in the process of turning liquid water into water vapor. By reversing this process, the latent heat becomes released. He pointed out that the released heat is rather substantial. He pointed out that the latent heat from cloud formation makes up 48% of the heat in the atmosphere, and that only 43% of the atmospheric heating comes from the sun. Obviously, some of this heat, too, becomes radiated into space, whereby, too, the Earth becomes progressively colder, with increased cloud formation. Professor Sergei Pulinets presented a study by Jasper Kirkby, the head of the CERN Cloud Project. The study shows a close relationship between increasing galactic cosmic ray intensity and decreasing general rainfall amounts. This tells us that the cosmic ray-caused cloud formation creates colder surface temperatures by which we have correspondingly less water vapor in the air and drier climates. The CERN Cloud Project, cloud meaning cosmic rays leaving outdoor droplets, is designed to investigate the microphysics between galactic cosmic rays and aerosols under controlled conditions, using a beam of protons from the CERN proton synchrotron. The experiment's spokesperson, Jasper Kirkby, said, "These new results from cloud are important because we've made a number of first observations of some very important atmospheric processes. We found that cosmic rays significantly enhance the formation of aerosol particles in the mid-troposphere and above. These aerosols can eventually grow into seeds for clouds." The CERN Cloud Project proved the principle of cosmic ray-induced cloud formation, though the small-scale experiment is insufficient to duplicate the cosmic ray-induced showers of secondary particles that extend over thousands of meters through the troposphere. In an LPAC video on the CERN results, a member of the LaRouche Science Basement team illustrates how strongly the cosmic ray effect has been demonstrated in principle. The first part shows the aerosol production without an electric field and without cosmic rays applied. During this part, the aerosol nucleation is extremely low. In the second part, an electric field was added, as would exist naturally, and as the result, the aerosol nucleation increased dramatically. In the third part, the artificial cosmic rays were added, and the increase went almost straight up. Professor Sergei Poulinets pointed out at the Schiller Institute conference in Germany in 2011 that the pioneers of the late 1990s were right on the mark when their study revealed back in the 90s that there exists a definite measurable correlation between the climate on Earth and cosmic ray density. The study he presents shows that cloud formation and cosmic ray density stand in close relationship with each other, and on an inverse relationship with solar irradiation received on the surface. The bottom line is that all the numerous studies show that galactic cosmic rays have a major impact on the climate on Earth, and may well be the single most significant forcing factor. What causes galactic cosmic ray density to vary? The cause is located in the Sun. The evidence that this is so has been provided by NASA's Ulysses project. It has provided some answers. Ulysses is a spacecraft that NASA has placed in a polar orbit around the Sun. This orbit takes it outside the planetary ecliptic to observe the solar winds from a perspective we cannot get otherwise. It has sent back some surprising data. The Ulysses spacecraft made 3 orbits. The first lasted 6 years, between 1992 and 1998, and the third orbit, from 2004 on, was cut short in 2008 when the mission was terminated. The mission team was surprised by the difference in the data for the solar wind pressure between the orbits. While the solar wind speed remained essentially the same outside the ecliptic at around 800 kilometers per second, the solar wind pressure was lower by 30% for the third object, shown in blue. No one expected this. The lower pressure in terms of the wind plasma density and temperature becomes reflected in a smaller and weaker heliosphere. The heliosphere is a sphere of plasma created by the solar wind. When the solar wind particles slow down, they become bunched up and create a shock front, called the termination shock, that forms the inner heliosphere. When the winds finally stop completely, they form a plasma wall, called the heliopath. The plasma in between these two structures is dense enough to block 90% of the incoming galactic cosmic rays, most of which are high-energy protons, some traveling near the speed of light. When the solar wind pressure diminishes, this shielding system becomes weaker. This is precisely what the Ulysses spacecraft has shown to have happened between its first and third orbit. Correspondingly, the Ulysses mission revealed a 20% increase in the cosmic ray flux density. Consequently, the greater cosmic ray flux density is reflected in increased cloud formation in colder climates on Earth from 1998 on. This is the result of the entire heliosphere becoming weaker as the result of a gradual weakening of the Sun. But what causes the weaker Sun? The weaker Sun is not a mystery, because the Sun is not its own master. The Sun attracts plasma with its immense gravity. The plasma is an electrically charged homogeneous mix. But at a great density, a charge separation occurs, and when the separation is great enough, an electric discharge arc begins. This is essentially what is happening on the surface of the Sun. That is where the radiant energy is forged. The evidence is in the sunspots. If the Sun was a nuclear fusion furnace powered from the inside, the region below the sunspots would be brighter instead of being darker. The sunspots are holes torn into this photosphere that let us look below it. This photosphere thereby reveals itself as being powered from the outside, electrically. The Sun is teeming with evidence of enormous electric activity happening on its surface in the photosphere. That is where all the vital activity is happening. The Sun is essentially an electric energy converter. Its output varies with the density of the electric plasma in space around it. At the ultraviolet end of the spectrum, the high-powered end, the solar intensity varies by a factor of 20 over the 11-year solar activity cycle. This dramatic variation hasn't spilled over into the visible spectrum yet, that remains steady within a fraction of a percent. But this too may happen as the solar input gets weaker. But where does this electric plasma come from that powers the sun? The energy that powers the sun exists with cosmic abundance. NASA's Hubble Space Telescope shows us that the stars are typically aligned into string-like groups. This phenomenon accords with the nature of electric currents flowing in plasma, which are magnetically self-aligned into long streams in which the stars are located that are powered by them. For the solar system, the nearest star is Alpha Centauri. It is in line of the plasma that is feeding into our heliosphere. The bow shock of our heliosphere is pointing towards Alpha Centauri. This is where the plasma stream for our sun is coming from. The interstellar plasma streams, being magnetically self-aligned, also attract plasma from nearby space, so that the density of these electric power streams reflects to some degree the plasma density in the surrounding space. It is here where the climate on Earth is determined to a large degree. It is here, too, where the pulses of the warm interglacial climates originate, like the one that we are presently in, which is in the process of ending. Our normal climate is an ice age climate, which gets periodically interrupted with short pulses of warm climates. The difference between the two states is large. Ice core samples from the Greenland ice sheet tell us that the normal climate on Earth is 30 times colder than the little ice age in the 1600s had been. All of this is determined by the plasma density in interstellar space. The interglacial pulses appear to be electric discharge pulses in nearby galactic space. The climate on Earth is also affected by two still longer cycles than the Ice Age cycles. These long cycles are 62 and 145 million years in duration. They establish the background for the general climate, including the Ice Ages. These extremely long cycles appear to be intergalactic resonance cycles. Like the stars in a galaxy, the galaxies too are aligned into filamentary strings, in this case along the flow of intergalactic Birkeland currents. These long strings have their own electric resonance cycles, which would be measured in tens of millions of years. We are presently near the low points of both of our long cycles, which created a deep low background in electric density in which Antarctica froze up, then Greenland, and soon thereafter the Ice Age cycles began. Since both of these long cycles have not yet bottomed out, we will likely see the Ice Ages getting increasingly colder for the next few million years. As human beings, we can live with all of that, because we have the capability at hand to relocate all of the northern agriculture that will become disabled by the cold into floating platforms strung across the equator, where our agriculture will be protected in perpetuity. Whether we survive the transition to the next glaciation cycle depends on how soon we react to the imperative that our climate science lays before us and begin to prepare our world for the Ice Age transition that has already begun.